Welcome to the solution to the area worksheet. So, first question, nice straightforward shape. Just make sure you read the question carefully. So this question said here's a rectangle. Work out the perimeter of the rectangle. So the perimeter is the distance around the shape, and that's all of the side lengths added up together. So it's a rectangle. That means that this side is 10 centimeters and the top side is 20 centimeters. Otherwise you couldn't tell because the diagram is not accurately drawn, so you can't measure this. You have to work it out. Now we've got this side here, so it's 20, and then we add this side here, and then we add this side here, and finally we add the last side. So 20 add 10 is 30, add another 30 is 60 centimeters. The thing with perimeter is to make sure you've got all the sides. So just double checks. We've got that one there, we've got that one there, we've got that one there, and finally we've got that one there. And the last thing is all of the sides should have the same units. These are all centimeters, so that's good. Okay, second part, work out the area of the rectangle. So the area of a rectangle, just a rectangle, is width times height, width times length, whatever you'd rather. So we don't need all the numbers, and this only works on rectangles. So we need the width, which I'm going to say is 20, although of course if you turned it round the width would be 10. So, and then the other direction is 10, 20 times 10 is 200, so there we are. And it's got the units, always check that the units are there. Okay, there we are. Okay, question number 2. There it is. Okay, work out the area of this shape. So this shape is a trapezium. I know most people think trapeziums have to be symmetrical. They don't. The thing that makes it a trapezium is the two parallel sides, and these are parallel here. Now, several ways of doing this. We could use the Trapezium Formula, which you should know about, or you could split the shape up, in this case, into a triangle and a rectangle and work them out separately. So first of all, I'm going to work them out separately. So this one here, we've got loads of numbers here. We need a width times height for the rectangle, so it's 7 multiplied by the 5, which is 35. Now the triangle, the area of a triangle is half base times height. The basis for the height is the same height as the rectangle, which is 5, so the triangle is a half of 4 times 5. So 4 times 5 is 20, and half of that is 10, so the triangle is 10. And the units here are square centimetres because we're dealing with area. So to get the total area, we add them together. 35, add 10, which is 45. And can I really recommend that you do write down calculations along the way like this, because although it won't necessarily guarantee the marks, there are 3 marks for this question, so it's well worth showing how you've arrived at the 45, and if you think something and you do it, just write it down and you may well get some marks for it. The trapezium formula from the beginning of the exam paper, the area of a trapezium is a half of a plus b times h, and next to it, rather conveniently, is a little picture showing you what a, b and h are. So a and b are the opposite parallel sides, and h is the height. So let's see if we get the same answer for this. So for our trapezium, a and b, the parallel sides, are 7, and the bottom here, which is 7 plus 4, which is 11. So we need to do a half of 7, which is the top, 11, which is the bottom, and we multiply it by the height, which is 5. So 7 and 11 is 18, so we've got a half of 18 times 5. Now a half of 18 is 9, and 9 times 5 is 45, so you can see you get the same answer both ways. Sometimes you can't split the shape up and you have to use the formula, so it's very worthwhile making sure you understand how to use this for trapezia. Alright, question 3. James has a pond for his pet crocodile. The pond is a perfect circle. Well, we're not interested in this crocodile business. It's the circle. We've been given the diameter, and this question is about area. That's all we're really interested in. It's the area of a circle. So you need to know a way to work out the area of a circle. There is a formula, and you need to know it. They don't give it to you in the exam. I often remember it using a little rhyme. So it's twinkle, twinkle, little star, circumference is 2 pi r. Didn't know you really cared, but area is pi r squared. Okay, so that's what we're going to do. So pi times r. Now, if the diameter is 10, then the radius, r, has got to be 5. So, because the radius is from the middle to the edge, that's 5. And it doesn't matter which direction you go in, it's always going to be 5, because that's what makes it a circle. So it's pi times 5 squared. Now, that's 25 times pi. At which point, you're probably going to want to reach for your calculator and type that in. So 25 times pi, and my calculator comes out with 78.53. Now, 53981 actually, and some more stuff. Now, if you don't know where the pi button is on your calculator, what you can do is you can use the number 3.14. Pi is a special number that's associated with circles, and it's always 3.14 and some more stuff, or you can use your button on your calculator. Okay, so I'm not going to write all this down as my answer, I'm going to round it off to 78.5. And I'm noticing that there's a blank here where units are. So this is about area. The measurement is in meters, so this is going to be square meters because area is measured in squares. Question 4, the challenge question. Calculate the area of this right-angled triangle. So, area, that's the key thing there, not circumference, not perimeter. And area is given for a triangle is a half of the base times the height. Now, which one's the base and which one's the height? Well, this is a bit of a tricky one. It depends which way you stand it. Now, if I put the 7 on the bottom, it would look like this. It would be a very tall triangle. That would be the 25, and that would be the 7, and that would be the height there. If I stood it on the 25 side, it would look like this. And that would be the 7, and the height would be that distance there. And how high is that? Well, that's not simple to work out, so the 25 is not a good choice for the base. Or I could stand it on the side we don't know, in which case it would look like this, and the 7 would be the height, but we don't know the base. What I'm saying is we need to do it one of these two ways. Okay, we can't, this is a very difficult one, this is. So we're going to need to work out this length here. And how do we do that? Well, we use Pythagoras, okay? So we work this out using Pythag. So there's 3 steps to Pythag. First of all, you square everything. So we've got 25. So 25 squared is 625. I put it in a little box there. 7 squared is 49. Now we have to decide whether we add or subtract. Now for this one, we know the long side, this is the longest side, and we want a short side, so we subtract. So we do 625, and then we subtract the 49, which gives us 576. Clearly that side is not 576 meters, that wouldn't make any sense, so we go to our third and last step, which is the square root. And that's why you need a calculator for this most of the time. And that gives us 24. So this side is 24 meters. But we haven't finished, have we? We want to work out the area. So the area is a half of the base times the height. And really doesn't matter which round you do this. This is the base and the height. And as we look from the pictures here, it just depends which way you stand it. A half of 24 times 7. So a half of 24 times 7 is 84, I believe. There we go. And finally, just remember to give the units. So I've foolishly written meters there where it should be centimeters, but notice how I'm thinking at the end. I'm thinking what are my units, so because I'm thinking that I can change them. And of course this is area, so this is square centimeters. This is centimeters because it's just a length, and this is square centimeters because it's an area. Hope you found that helpful.